Hi guys, so sorry to miss you this week. We just had a whirlwind trip down to Wisconsin and back, but I was very sorry to miss you and sorry to miss the opportunity to say goodbye to you guys. It's been a really great year, and it's been wonderful to get to know you and to work with you through a lot of the major issues in human geography. So I think you all have done really well, and I've been impressed by your skills in analysis and your willingness to participate in class and participate in looking at some of these big issues, talking through them, debating them. And I wanted to kind of wrap up the year by looking at some of the major issues we've looked at lately. As we've seen over the last few weeks, one way to kind of break down some of the future of the world and the future of human geography, the impact that humans will have on the environment and that the environment will have on humans, is to break it down in terms of elements: air, earth, fire, and water. And so we've done that over the past few weeks, and I wanted to give us one more resource looking at each of those elements. Air, of course, being air pollution, water being water quality and usage, earth being agriculture, and fire being energy use. So I've sent you guys links to 4 resources that have to do with each of those, and what I want to do in this video is to look at each of those and so for the videos, I'll just ask you to pause the video. I'll ask you to pause this video. Ask you then to go to the video or the resource and either watch it for the first time if you haven't watched it, or just give it a quick second look, and then come back to this video and participate a little bit in the discussion. So let's first take a look at the article about air pollution, which is under the link that I put after the word air in the email I sent you last week. Okay, so as we look at this article, this is an article by Earthscene, which is a semi-reputable source. But what I liked about this article is that it broke down this report done by the journal Atmospheric Chemistry and Physics, which is also a reputable journal. And what it did is take me a look at pollution going forward, right? So, one of the things that we, have looked at is what is happening to air quality. Why does it get worse and better? What can we do about smog? What can we do about greenhouse gases? And what are the best ways to avoid and reduce air pollution in the future? So this article does a good job of looking at what this journal and what this group of scientists has predicted air quality will look like going forward. You can see, in this map that they give at the top of the article, that we do have pollution in local areas, but whatever pollution goes into the air is shared around the world. It's the nature of gases to expand, and they expand ultimately to fill the entire atmosphere at very, very, very diluted levels, right? So so the molecules in gas tend to spread out, essentially infinitely until they populate all over the atmosphere. So pollution in China does reach us in some ways, and our pollution does reach China in some ways. So it's important when we think about pollution that it's not just about the people who are immediately affected, but also the impact on the air quality globally as well. So this article, I would like you to go ahead and read the full article, but I'll point out a couple of highlights. One thing that they point out is that the World Health Organization, an extremely reputable organization, that is a United Nations organization, and they do a lot of great statistical data collection. They found that outdoor air pollution causes 1.3 million deaths per year. That is obviously something that we can avoid with the right solutions. So we have one other highlight here is that we have a high level of carbon monoxide, as shown here, where we're getting up to 250 parts per million. That means, per, say you have 1 million liters or 1 million, quarts of air, of that 1,250,000 of them are pure carbon monoxide, right? But of course, that carbon monoxide is diluted across that, million parts. Carbon monoxide, of course, is a gas that can kill you, and we looked at some of the effects of carbon monoxide in a couple of videos on a PowerPoint and discussion in class. But we're also looking at higher levels of pollutants such as nitrogen dioxide, sulfur dioxide. These are released by vehicles, coal burning, and even campfires can reduce some of these gases as well. There's also fine particulate matter, so in other words, basically a really fine dust that's in our air. And we're looking at that persisting, especially in East Asia, over the course of the next 35 years or so, if nothing changes. Now, one of the things that this article suggests is that we need legislation to change this, and that may absolutely be the case. One of the things that I think we've focused on a little bit in class is that it's important to discuss problems and get a real sense of the problem before proposing solutions. So legislation might be a solution here. There also might be market solutions. It may be the case that as we get more renewable resources, renewable sources of energy on board, that this will reduce as a result. So we're going to get less coal burning, as we see, for example, coal plants closing across the United States and new coal plants not opening, even in places like China. So we see a slowly declining demand for coal and increasing demand for renewable sources. Of course, also changing the ways our cars operate slowly over time can reduce this as well. So this report doesn't entirely account for technological change, but of course that's practically impossible as well. So it is important to pay attention to this, whether or not it's whether it's legislation, market solutions, community organizations, or whatever it is, awareness, reduction conservation on an individual level or government level. That's important as well. So that's this article. I would like to read it and just see the details there. But that is the article about air. All right. Here is our second article, this one about water. So this is a really interesting article. It's a little bit longer, quite a bit longer than the other one, but it is an interesting read for a couple of reasons. One, it talks about how complicated the effort to protect waterways can be. And then second, it also talks about the different chemicals that are problematic when we look at protecting our waterways and wetlands. This one is about Chesapeake Bay, and I'll show you quickly where Chesapeake Bay is. Chesapeake Bay is sort of between Maryland and Delaware. Its watershed is eastern Maryland, southern Pennsylvania, and western Delaware. So that means that there's quite a bit of land that flows into the Chesapeake Bay. And of course, it's not just land that's on the shores of Chesapeake Bay, but also the waterways that run into it, like the Potomac River and all of the rivers and streams that feed that river, as well as other rivers and waterways. So this was an article published last year, in fact, almost exactly a year ago, and it talks about the effort to quote-unquote save the bay. Chesapeake Bay has been subject to this dead zone, which results when chemicals are put onto surrounding land, chemicals like phosphorus, which is a fertilizer and encourages plants to grow, but it also encourages plants to grow not only on farmland or in lawns, but in water as well. So when you get too much phosphorus in water, what that does is creates huge algae blooms. All that big thick green stuff covering the water. If you've ever looked at a pond covered in green stuff, that's algae. That algae can create a dead zone for two reasons. One, it uses up a lot of the oxygen in the water, so fish and other aquatic life have a hard time living in it, but also it blocks the sunlight, so plants underneath the algae can't grow. So algae creates a dead zone, and too much phosphorus in the water really encourages algae to grow. There's even another problem with algae, and that is if there's enough of it, it can create a toxic chemical that if it gets into the drinking water can harm both animals and humans. So this is a plan to protect waterways that was started by the Obama administration. And for this family, which we see up here in the top, they were given government incentives and funds to plant native trees and plants near one of the streams that feeds in the Potomac River that then, of course, feeds into the Chesapeake Bay. Now, that money was nice, but they did have to give up some of their productive farmland. So it's a real balance between you know, what some might call government interference, and you know, others might call protecting, you know, the environment. And of course, sort of both are true in some ways, no matter which, you know, quote unquote side you agree with. It is important to sort of balance the needs of individual people with the needs of the environment, or at least politically we have to do that. So how do you do that? How do you really protect the environment while still trying to balance people's needs? So what this buffer does, so instead of putting farmland right next to this creek, instead they planted native trees and grasses. And what that does is absorb some of those nutrients put onto the farmland. So while they flow toward the creek, they are held up by the roots and leaves and soil that are at the side of the creek, and those chemicals are filtered out to an extent. One of the things that this article talks about is how in the 17th century the Chesapeake Bay was just had a ton of wildlife, aquatic life, you know, oysters and crabs and sturgeon and rockfish and trout. And now we've got kind of this big dead zone where we don't see those animals anymore, or those, you know, aquatic life anymore. So the Clean Water Act was which was passed in the 70s, is one thing that has protected waterways. President Reagan provided more funds to the EPA in the 80s to protect waterways, and Obama passed a new legislation to protect waterways as well. But there, and here we have we've talked about kind of the history of how they got to this point, how they collected the data that they needed to figure out that this was one way to save the Chesapeake Bay. As we go deeper into the article, it shows, or it talks about some of the advantages and disadvantages of doing this. One of the disadvantages is that it may or may not work. You know, in order to have enough plants to filter off the runoff going into this creek or the Chesapeake Bay in general, you know, you might have to have a whole lot of land that is now farmland or, you know, lawn turned into more wild areas, and that's problematic for landowners. Also, whether you plant native trees and grasses, and now, you know, they have to grow up and you know, populate and grow over, you know, several years to see if this even works. So, you know, we also have, you know, complaints from industry groups and, you know, agricultural conglomerates who, you know, are a little bit skeptical of this plan. And then, you know, then it's just the question of whether or not this is working. And so, you know, the main discussion, you know, I wanted to, you know, have as a result of this article is some of the questions I wanted you guys to think about. That is just, you know, kind of what, you know, how do we protect waterways in a way that works, and in a way that works not only environmentally but also in a way that allows people to at least manageably you know, use the solution. You know, so if you're really making a bunch of farmers mad by kind of like coming in and demanding that they change their land, you know, it probably won't work politically. So these are just some of the challenges we see. So I'd like you to read this article, and I think it's only about this long. By the way, with this link, I think it takes you like up to another article at the top here, and you have to go, you have to go underneath here, and there's a lot to read here. 5 articles about the future of water. So this is, I think, the first article after the introductory part. So just start on this article, The War Over Chesapeake Bay. If it isn't obvious, I'm recording this in parts. I want to talk to you guys about the film, The Future of Energy, that I gave you a link to, and I think I put the word fire in front of it because it's about energy. Let's see what the title is The Top 10 Energy Sources of the Future. And I want to talk about a few of them here. The exciting thing about this, for me, is that we have a very exciting future in energy, and not only because we're going to have cleaner energy, but also because we're going to have energy that is not dependent on a single source, right? So we can produce our own energy by having solar panels in our house, and if the power goes out in our neighborhood, we can still have power, especially if we're saving some of our solar power with batteries and stuff like that. But I wanted to talk about a few of the sources of power that we see in the video, not all of them, but a few. So first of them one of them is space solar power. So in other words, if we were to position solar panels up in space, so there is the advantage of increased efficiency there. There is the disadvantage of how do you get that power back to Earth in an efficient manner. There also, by the way, this is connected to the idea of a megastructure, and that's something that that some scientists have theorized we could create in the future, and that is that we surround an entire star with solar panels and collect all of the energy, or 90% of the energy of that star, and that would be in the far, far future, of course, but when the human race would need that much power, we could collect the energy of, wouldn't be our sun, but maybe another star. And there's also a theory that perhaps this is something that alien civilizations have already made. So, it depends on how much stock you want to put in that. But scientists do see some strange dimming from a certain star in the Alpha Centauri system, so who knows? Maybe aliens have already built these giant megastructures. I also want to talk about human power. I just had a question mark about that one. I mean, I think human power is cool, and maybe we've all seen the radio you can wind by hand for emergencies, or the flashlight, you can wind, by hand, and that's cool. I don't think that's going to solve the world's energy problems, and in the video they said every little bit helps. I'm not sure what kind of impact human power is honestly going to have for an energy future where we're using, trillions of watts, trillions of kilowatts, in fact. But tidal power is a reasonable one. That's when you put a turbine underwater in the ocean, and as the tide moves in and out over the course of a day, you would turn that turbine and create electricity that way. Similar to hydropower, where you would put that turbine into moving water. This is, of course, putting it in a different source of moving water, that of the ocean during tides. So that's kind of interesting. I think that's already has a bunch of applications around the world. It hasn't been used as much as hydropower. I think the most probably frequent use of hydrogen power is either in hydropower is either in a dam or in a waterfall, something like that. So hydrogen power, that's another question mark. Sounds great. Yes, they use it for the space shuttle. Yes, we have been able to create hydrogen fuel cells, but the problem is that usually we get hydrogen from water, right? So we split the hydrogen off of a water molecule. So remember, if there's one chemical equation you might remember, one molecule you might remember, it's H2O. That means 2 hydrogen and 1 oxygen together. You hook those together and it makes a molecule of water. Well, if you split off that hydrogen, you can collect that hydrogen. The problem is it takes a lot of energy to split off that hydrogen. So sometimes you actually lose energy in the process. In other words, we're using coal burning energy to produce the electricity to split off the hydrogen, and then hydrogen to run our cars. Well, we've already used that coal energy, so we're not really saving any money or energy, and certainly not helping the environment, perhaps, unless the technology improves. Geothermal heat, that's collecting the heat of lava, of volcanoes, or from the lava underneath our mantle. And that's used all over the country of Iceland. In fact, I think that Iceland is able to get 90% of its electricity produced, its energy and in general produced by geothermal power. So that's an interesting country to look at if you wanted to look at a country that's using a lot of renewable energy. That and Germany. China as well, as we've talked about in class. Okay, also biofuels. I wanted to mention this quickly. I think this is like number 3. Biofuels are great, but ethanol has been a failure. We see that it takes almost more energy to produce a gallon of ethanol than a gallon of ethanol actually gives us. So we've had to really heavily subsidize that. And when we look at renewable energy, we want the energy to actually be renewable, not to be too expensive to produce, or actually harm the environment by using more energy to produce it than the energy that particular energy source gives out. So a gallon of ethanol, it takes more than the energy of a gallon of ethanol to produce in some cases. So, but if we look at algae might be a more efficient medium. Instead of ethanol is produced from corn, so perhaps from algae we can get a biofuel cheaply and with little energy, which would be beneficial to everyone. Finally, the flying wind farms, which is interesting. Of course, we want them flying because the higher you go, to an extent, you get faster wind speeds or more consistent wind speeds. So one of the problems of windmills is that the wind doesn't always blow, but if you get high enough up in the
in the thermosphere, perhaps we can get a more consistent wind source. So that's the advantage there. All right, I'm going to move on to the last video and talk about that for a little bit. Guys, I want to talk about the final video, and that is the future of vertical farming. So this is a continuation of our discussion of vertical farming in class, and I wanted to talk about a few of the things that, some of the details we didn't get a chance to talk about in class. So, and as a reminder, this final class, this final lesson here, this final video, is really about, what's the future? So we've discussed the past, we've talked about ancient civilizations over the course of the semester, of the year. We've talked about historical uses of land, the development of cities, migration. We've talked about a host of topics, and now we really wanted to focus on the future, and that's what the last month or so has been about. And this final class is a wrap-up and summary of that. So this last video, a little bit of a sum-up of the future of agriculture. I think perhaps the most interesting future of agriculture, or maybe the most radical departure from agriculture, might be vertical farming. Now, whether or not this will actually be our future, who knows? But it is something being tried. We do see it. We do see applications around the world. And the question is, can we make it efficient, cost-effective, and good for the environment at the same time? So one of the things the video mentions, and by the way, this is only about 2 minutes, and then it goes into a picture of just a bird outside feeding at a feeder. So it was a really, I thought, succinct and good discussion of vertical farms in a very short amount of time. So he mentioned passive solar, that is, creating homes that are facing the sun so that they're heated properly in the winter and cooled properly in the summer. And that's an interesting topic that I think is worth exploring and researching in its own right. But, there's one major reason for vertical farms, and that is the distance between farms and the city. The fact that the farms are so far outside the city, and there's transport costs, and also just the fact that our food isn't quite as fresh because of the transportation from one place to another. So what vertical farms promise, whether or not they can deliver is the question, but one of the things that they promise is that they can reduce land use, right? It mentions in there that one 30-story vertical farm that is 1 block wide and 1 block long can produce as much as 10 square miles of farmland. I think that's an ideal projection. We have not seen that happen yet, but that would be really cool if it did. So it reduces land use, it reduces water use, and we talked about that in detail in class, so I don't think I have to go back into that. It also could cool urban environments. Generally, the city, Minneapolis, St. Paul, is about 5, maybe even more degrees Fahrenheit warmer than the surrounding land, and that's because we have so much concrete and brick and stucco and all that stuff that collects that heat from the sun. We don't have forests and grassland that can absorb that heat. So we sort of reflect that heat, and we sort of work, we don't reflect that heat, we work as a heat sink. In other words, the heat stays with us more than it would in a natural environment. So a vertical farm could help reduce that impact, though one building isn't really going to do it. So we'd have to have quite a few of them. Of course, it reduces transport costs as well. And we can not only one of the ways we can reduce water, and we talked in class that vertical farms can reduce water usage by up to 90%, which is pretty amazing. But it can also we can also as part of that recycle the water that is used in the farm. So that's one of the ways to get that reduction. Also, of course, you have much higher density fields or containers in a vertical farm than you would be able to have out in nature, because you need to drive tractors through there or run irrigation systems through there. So the density is just much higher. Also, the author mentioned we can use fiber optic light or LED light, and that can really reduce the cost of the electricity used in the building. Of course, remember that outside we don't need to use any electricity. So there is electricity being used in a vertical farm that you would not use outside, of course. There's a couple objections to vertical farms that I think are worth listening to. It's always good to understand all of the reasons and objections to any problem you're trying to solve. And and remember, vertical farms are a solution to a problem, not a problem in themselves. So It may be the case that in vertical farms, they grow crops that we don't want. So in other words, it might be really energy intensive to, say, grow broccoli or to grow zucchini or to grow potatoes, for example, in a vertical farm. Potatoes would be probably especially challenging because they do generally need soil to grow. It could be that innovations in horticulture would change that. But potatoes would be like a crop that would be difficult to grow. Carrots, perhaps, would be a crop that's difficult to grow in a vertical farm, or more difficult than others. We saw in the videos we watched earlier, not this video, but the videos we watched earlier in class, that some of the crops that are relatively easy to grow in a vertical farm include spinach, include lettuces, romaine, lettuce, etc. We saw radishes, we saw tomatoes, we saw peppers. But we didn't see a lot of other plants. There wasn't a lot of diversity in the vertical farms. Finally, agribusiness might push back. In other words, these big, relatively influential and powerful people in the business of producing and selling and transporting our vegetables now might not like the idea of vertical farms because they might have some advantages. Of course, so that is a good objection. Perhaps there would be some pushback, but probably going forward we would see that agribusiness, major agribusiness conglomerates, I'm trying to think of some off the top of my head, but they might get into vertical farms. So it may be the case that agribusiness pushes back. It may be the case that agribusiness gets into the business itself, as we've seen with renewable energy. British Petroleum and other companies have gotten into renewable solar panel manufacturing, for example, so renewable energy production. So, all right, well, this is the end of not only this review of this video and this discussion of this video, but also the end of this video. And I wanted to say thank you guys again. It's been wonderful to spend the year with you. I think you all did great. I would encourage you over the course of the summer, take a look at those maps. Make sure you know where everything is in the world. And spend some time looking at your local environment, even studying a map or two, and see what you can glean from the world around you. Thank you guys, and I will see you at the picnic or next year. Bye.